Okay. We are being recorded right now. Okay, so we're going to go and do some practice problems here. The questions that you had. This is our review of trig identities and trig equations. All right, so when I do this equation, I'm going to set it equal to 0 because the zero product property is our best friend in mathematics, right? So we're going to say sine of 2x cosine x, and this is from 5-3 homework, minus cosine of 2x sine x equals 0. And then I'm looking at this and I'm saying, gosh, that looks like sine, cosine, cosine, sine. That looks like sine, cosine, cosine, sine. That sounds like an identity to me. It's like the sine of a difference, isn't it? So this would be the sine of 2x minus x equals 0. Do we agree with that? Well, what's 2x minus x? So when is the 0? Oh, this is so whenever is the 0? Down here, right? On the x-axis. So if I'm doing the general solution, this is going to be x equals pi n, an element of the integer set. Now, Ms. White, does it give us an interval or does it say general? Okay, so we're going to do general. Wow, that was a sneaky way to say I want to solve sine x equals 0. Okay, but what was the visual clue that we could make it easier? Noticing that this was sine, cosine, cosine, sine, right? And the signs stay the same. Remembering that the sine of x minus y is equal to the sine of x, cosine of y, minus the cosine of x, sine of y, right? That's the sum of difference identity that we need to know. Okay? So I'm glad we did that. It's a nice thing to do. Now, could we have theoretically expanded this? Wow. Yeah, no, I don't want to get you. No, this is so much easier if you can recognize that. Okay, so let's go to the next one. This is 17 from 5-4. Ms. White, can you tell me what our instructions are? I'm sorry to put you on the spot like that. Verify.
It's for the identity.
Okay, so it's verified. So, all right, well, I absolutely don't like the fact that we have a 2x on the left. Do you guys not like the 2x? I don't. So, but what is this cosecant of 2x equal? That equals 1 over the sine of 2x, right? So that's my first thought. Remember, I like to do my little thought bubbles here. That what is it? Cosecant 2x is equal to 2 over sine of 2x, right? Which is 2 over 2 sine x, cosine x, or cosine x, sine x. It doesn't really matter which order you're in, right? Do you agree with that? Okay. So we have to decide which side we're going to use. I think it's going to be easier to manipulate this side. Maybe. So let's just choose the right side. So I'm going to say cosecant squared, I'm going to change into 1 over sine squared x. Do we agree with that? Okay, and then this is going to be sine x over, oops, this is sine. Over cosine x. Can I simplify that? I can get rid of, I'm going to write this. I can get rid of one of these, and I'm left with 1 over sine x cosine x. Now, why am I I'm happy to see that arrive on the scene. Because I'm like close. What do I have to do to this? Multiply by a favorable factor of 1, which would be 2 over 2. And that's 2 over 2 sine x cosine x, which is the same as saying 2 over, what is this equal? Sine 2x, which is equal to 2 cosecant 2x. Yay! And sine our work, I believe. And what would this one be? Not out much, right? Okay. So that one was a little bit difficult, but what were my strategies? I didn't like this, right? I didn't like this, and I thought it would be harder to get to this. So I thought, okay, well, what does that equal? And maybe I can manipulate that side to get there, right? So am I in my work? Am I touching the side? No, I'm thinking about it, and what I'm writing on paper in the bubble. I won't look at what you have in the bubble. So it's okay if you use a bubble to be thinking to help you, right? But that's not, I will think that you're not really touching that side yet, but you're trying to figure out what the right side needs to look like to match it. Yes, ma'am.
How do you get sine 2x equals 2 sine x cosine x?
Okay, that's a great question. So, oops. Sine 2x equals 2 sine x cosine x. How do I get this to match this?
Take it as sine of x plus x.
That's right, you take it as sine of x plus x. And then we're going to expand this using the cosine sandwich. Remember sine, cosine, cosine, sine. So this will be sine of x, cosine of x, plus the signs stay the same, right? When we have x, we're using the alliteration to help us, plus cosine x, sine x. And there's 2 of them here, right? So it's 2 sine x cosine x. So that is an identity. That's how you derive the double angle identity. Okay. So that's why I think you absolutely should have this one memorized. Good deal. Okay? Good question. Next. Okay, for cosine of 4x, I don't like that. But I do know that I have some squares over here that I can reduce the power on. Okay, so we need to recall what the power reducing identities are. Sine squared x is equal to 1 sinus subtraction, 1 minus cosine of 2x over 2, and then the cosine squared is nothing more than the addition. So I like to remember this one as sine is subtraction in this case. Okay, so I'm going to work on the right side to make it look like the left side here. Okay, so I'm going to have to put the equals over here because I have this work. I think I can make it smaller. And I'm cheating, but yeah. I'm sorry you can't make it smaller on your paper, but I can. Okay, here we go. So this 1 is not going to change. Minus 8 times, well, what is sine squared equal? I got it right here. 1 minus cosine of 2x over 2 times cosine squared is 1 plus cosine 2x over 2. And then this is 1 minus 8. Now, 2 times 2 is 4, right? 8 over 4 is 2. So I'm just gonna put a 2 out here. And then I'm left with 1 minus cosine 2x times 1 plus cosine 2x. But that looks like something I could multiply out easily. Give her the squares, yes. Okay, so this would be 1 minus 2 times 1 minus cosine squared of 2x. You agree? Now I'm going to reduce this power. And you're like, wait a minute, I just had it unreduced. But what do I need? I need a what on this side? A 4x. And if this is x and this is 2x, if this is 2x, what is this one going to be? 4x. If this was 3x, this would be 6x, okay? So you can, fix that. So we can say 1 minus 2 times 1 minus, well, I'm going to substitute now the power reducing here, and we're going to say 1 plus cosine of 4x. Good, and I'm really happy to see that 4x all over 2. And I'm hoping some of this will cancel out. All right, so let's see what happens here. We get 1 minus 2 times, I'm going to get a common denominator here, which is 2. So I can multiply this 1 by 2 minus, and I'm going to distribute the negative, 1 minus cosine of 4x. All I do is distribute the negative and found a common denominator. And what happens here? That's nice. Do you agree? And then 2 minus 1 is? Not all at once. And then if I distribute this negative, I get 1 minus 1 plus cosine 4x, and I get cosine 4x equals cosine 4x, and I'm very happy about that. Now there are multiple ways that we can get there. Now what are we going to call this one? Yes, sir.
On the remember part, I think the sine squared of x is equal to 1. Where did you derive that from? And where the denominator should come from?
I derived that from the cosine double angle is equal to, there are 3 versions. There's the mixed version, which is cosine squared x minus sine squared x. And where do we get that from? If I go cosine of x plus x, and I cosine, sine, sine, you're going to get cosine squared minus sine squared. That's where that comes from. That's the derivation of that. This is the mixed version. It's mixed because it has sine and a cosine in it. There's an all cosine version, which means, what am I going to do? I'm going to substitute in here for sine squared and make this 1 minus cosine squared. When I do that, I get cosine squared minus, we'll work it out, cosine squared x minus 1 plus cosine squared x, which is 2 cosine squared x minus 1. I call this the all cosine version of the double angle. Now why is it the all cosine version? Because it has only cosine in it. What about the all sine version? I'm going to substitute instead, I'm going to substitute in here 1 minus sine squared. So it'll be 1 minus sine squared minus sine squared, which is 1 minus 2 sine squared. That's which is the all sine version. So the cosine double angle is equal to this, is equal to this, and is equal to this. It's absolutely essential that you have those three numbers. Yes.
I was confused with how you got 2 in the denominator.
Okay, I'm not done yet. Okay, so do I know what sine squared? So I know cosine of 2x is equal to 1 minus 2 sine squared x, right? So I'm going to take this and I'm going to solve for sine squared. So what do? I'm going to move this whole thing over. So I'm going to get 2 sine squared x equals 1 minus cosine 2x, and then I'm going to divide it by 2. That's how you get the power reducing one for sine squared. And you do the same thing to solve for the power reducing one for cosine squared, except you're going to use the all cosine version. Yes.
How do you know for like the problem to like go into just give us more time?
Okay, because I knew that the only way I was going to get any argument that was other than x, I was going to have to, use power reducing formula.
So if there's anything with like a number and then like we should,
The power reducing is probably the way to go. Yes, ma'am. Yes, ma'am.
Do you know, the formula or the thing, or know how to derive them?
I would, yes.
And would you know how to derive them?
If you forget, then do you know how to get them? Okay, so you can memorize them, yes, or let's say you've memorized them and you're in panic mode on the test, but you know how to derive them. Are you safe? Yes. You see? So it's in your best interest to know where they come from, so that in a panic moment, you can always go back and say, well, how did I get that in the first place? So, okay? Great question. All right, this is 27 from that same section. Are the instructions?
Solve algebraically for exact solutions in the interval, including 0 to 2 pi. Use your graph model to solve the algebra.
So we're solving between 0 to 2 pi open and use your grapher to verify, is it said?
To support the algebra.
All right. Wow, what don't you like about this? Yeah. So how are you going to manage that? Yep. So this is going to be sine 2x plus sine of 2x plus, am I right? X? No. That's a long day for me too. You agree with that? Now I'm going to leave this because I just want to see what happens here. Sine 2x plus, now this is going to be the cosine sandwich, right? Sine, cosine, cosine, sine. So it's going to be sine of 2x, cosine of 2x, the sign stayed the same, plus cosine 2x, sine of 2x equals 0. So we have sine of 2x plus, well, how many of these do we have? 2, so this is 2 sine 2x cosine x, cosine 2x equals 0. Connect that. This is common to each, isn't it? Oh, yes. Yes, it is common to each. So I can factor that out. So this will be sine of 2x times, what's left? Now I'm going to
That's right.
Okay, well, we love you, so we're gonna have to deal with that, right? Okay, now, I could use U substitution here, right? Sine 2x equals 0. And then I have 1 plus 2 cosine 2x equals 0. So we get, where's the sine equal to 0? Because sine of u is equal to 0. Here and here, right? So what does u equal? Good, pi n, and an element of the integer set. Now I know I'm going between 0 and 2 pi, but let me show you how I do it, okay? So, but u is equal to 2x, so 2x equals pi n, and an element of the integer set, and then x equals pi over 2 times n, and an element of the integer set. But I only need to answer between 0 and 2 pi, so I'm going to let n equals 0. Because n is an integer, right? If n is equal to 0, I get x equals. What happens when I let n equal 1? Oh, nice. What happens when I let n equal 2? Alright. What happens when I let n equal 3 pi over 2? Now I can let n equal 4, but then remember my interval is exclusive of the 2 pi, right? Now, what do we know about in the u-verse? I have how many solutions here? 2. So I should have how many in the x-verse? Double that, right? So this is 4. That's the first side. And now I have to see this side. So this is 2 cosine 2x equals negative 1. Cosine 2x equals negative 1/2. Cosine of u is equal to negative 1/2. What quadrant is the cosine negative? 2 and 3, good. So I got to figure out what alpha is. Pi over 3, good. So u equals plus or minus 2 pi over 3, correct? Because I could go this way, positive 2 pi over 3, and plus 2 pi n, and an element of the integer set. But u is, happy this problem's on the photo. U is 2x. So this is 2x equals plus or minus 2 pi over 3 plus 2 pi n, and an element of, oops. Okay, now I'm going to divide by 2. So x equals plus or minus. Good, pi over 3 plus pi n, nice. And an element of the integer set. Now how many solutions do I have? And this is, remember, this is u. 2, so I'm expecting 4. So I need x equals, I suspect I need the pi over 3 angles, don't I? All of them? Between 0 and 2 pi. So if I let n equal 0, I get plus or minus pi over 3, but pi over 3, remember we have to live between 0 and 2 pi. So the negative pi over 3 doesn't work. But the 5 pi over 3 will, won't it? Yes. And then I can add, what happens when I add pi over 3 plus pi? No. Pi over 3 up here plus pi. Excuse me. 4 pi over 3. What happens when I take negative pi over 3 and add pi? And then get your 2 pi over 3. Yes, ma'am.
So that's gonna ask for all solutions, but if they're asking for general solutions.
No, if I'm asking for general solution, okay, I'll highlight it. This is general. The black box answers are between 0 and 2 pi.
Or the all solutions.
This is every solution in the blue in the universe, right? These are the answers that are between 0 and 2 pi. Sure. I just want to see the triangle so that you know which quadrant you're in. I think that helps everyone. Okay? On a scale of 1 to 10, difficulty of this problem?
8.
8. I think 8 is probably about right, 10 or 8. Okay, so the strategies on this problem. We didn't like the 4x, did we? But we had a 2x here, so we could change it. And then the rest fell out pretty nicely, didn't it? So why did I hold off on the sign of 2x over here? Because I could have changed that to 2 sin x cosine x. That's right.
Because you were always on the side to the
Because I knew I was going to have a bunch of 2x's over here, and I thought, well, maybe I might be able to factor it out. And sure enough, it worked. Okay? So we could go to town and expand all of these, but we don't have to if we use u sub and everything's 2x. Does that make sense? I mean, it makes your life, you know, you don't want to be crying right now. You might be anyway, but. All right, here we go. Let's do the next one. 39. This is a verify, I suspect. To verify. Now, I'm going to ask you a question. We have 2x and 4x on the other side, Meredith. So what do you think we're going to have to use? The power reducing ones. You're absolutely right, because those are the ones that have. Here, let me get my result. I'm going to copy it right on the sheet. I'm really sorry, but I can do this. And you can't. I'm really sorry, but we're friends here, right? We can do that, right? There we go. So I'm going to work on the left side because I can expand using power reducing. All right, here we go. So what is sine to the 4th? Well, that's just sine squared x times sine squared x, isn't it? And can I replace each of these with the identity here? Okay, so let's do that. We get what? 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2 equals, and then I'm going to pull the 1/4 out in front. Are we okay with that? Because 2 times 2 is, so this is 1/4. And then what's left here is I'm squaring this, aren't I? It's 1 minus cosine 2x times 1 minus cosine 2x, and I can expand that, and what happens when I do that? I get 1 minus, well, this is going to be a minus cosine 2x plus a minus cosine 2x, which is minus 2 cosine 2x. I'm happy to see that because what? I have the cosine 2x over here. Plus, what happens here? Cosine 2x times cosine 2x is cosine squared 2x. But what do I need? I need a 4x. So I'm going to change this to the 4x. Whoops, wait a minute. So this is 1/4 times 1 minus 2 cosine 2x plus, well, what can I replace that with? Well, 1 plus cosine 4x, because this is a 2x. If I use a 2x here, this is a 4x over here. So this is going to be over 2. Okay, so let's simplify a bit. We get 1/4 times 1 minus 2 cosine 2x plus 1/2 plus cosine 4x over 2 equals, and where am I headed? I will remind myself where we're headed. I need a 1/8 out in front, so I need to factor out a what? A 1/2. So if I do that, I get 1/8. And then things that don't have a 1/2, I'm going to multiply by 2. So this will be 2 minus 4 cosine 2x plus 1 plus cosine 4x. And now let's simplify, because we have the 1/8 outside and we're really happy. And so 2 plus 1 is 3 minus 4 cosine 2x plus cosine 4x, and please tell me that equals the other side. Yay! So what are we going to say about that one?
Thank God.
Amen.
Okay. So what was the strategy? I used the left side because I could use the power reducing. And then I expanded them, and then I had to use the power reducing one more time to get the 4x. Okay? One more. Let's see. Whoops. Okay. I guess I'm gonna, shoot again and put my power reducing identity right here. But I suspect we're gonna do it again.
Maybe.
Yeah? Well, okay, so this is sine cubed 2x, and I have what sitting over here? Oh, one of them 3, don't I? So I'm going to put sine 2x here, and then this is going to be sine squared 2x. Oh, hold on. I chose the left side because it's easier to use the power reducing identities than to go backwards from the cosine 4x. Okay, so I would always choose this side on the left. Okay, so I'm going to have to use the power reducing identity on the sine squared 2x. Is there a way to do that? Well, if I have a sine squared x equals 1 minus cosine 2x over 2, if I have sine squared 2x, this is going to be a cosine 4x, which makes me very happy because I see that on the right-hand side. So this is going to be sine 2x times, well, what am I going to put in its place? Good, 1 minus cosine 4x over 2, and do I just need to rearrange the writing and I have it? You're like, yeah? So this is 1/2 sine of 2x times 1 minus cosine 4x, and that indeed matches the other side. Oops.
There you go.
We're feeling a little bit better about power reducing? I'm not sensing it, but maybe it'll just, it isn't it?
We'll just apply it.
Rita, this is from the review guide. Yes, ma'am. I'm sorry? If we have time, we'll go back, okay? the mid? This is the mid one, mid unit review. Okay, so, we need to get you one of these. Do you wanna, I need to have you hobble over to Mr. Miller's room, and it's, just say I need to.
I mean, I'll get them.
And then, it's in the back in the corner, he'll tell you where it is. Just don't twist anything on the way over. Okay, I have a choice here, I have use the left side or the right side. I would use the left. And I need one trig function, don't I? What do I need on the right? I need a cosine. And tangent has sine and cosine in it, but secant doesn't. But I wish there was a way I could change that tangent into something that had only cosine or secant in it. Tangent squared x, you're right, is equal to secant squared x minus 1. So I'm going to change the left side here to secant squared x minus 1 over secant x plus 1. I wonder if I could factor. So this is going to be secant x plus 1 times secant x minus 1 over secant x plus 1. Wow, that was kind of handy. Why? These cancel and I'm left with secant x minus 1 equals, but I need cosine, so what do I need to do here? I'm going to change this to 1 over cosine x minus 1. And how do I get only cosine? I'm going to have a common denominator, yes? Which is cosine x, which would be 1 minus cosine x, and we're happy, hallelujah.
I got a way different way.
That's all right, different way is fine. So what are we gonna say this one is? What? I don't know if I've done this one yet. Okay. Could you, from the very beginning, have changed this to sine squared over cosine squared? And then 1 over cosine x plus 1. Found a common denominator and flip this, and this would fall out of it. Yes, you can do it that way as well. Absolutely.
Much longer.
Okay. But what did I recognize? I knew if I had all secants over here, it would be a really easy fix to get the cosines, didn't I? And we can change, using our Pythagorean identity, the tangent into a secant really quickly. Okay? So don't feel bad if it takes you more than that step. So, you'll get there eventually. All right.
You got the unit right here.
You want to do that? Yeah. Okay. All right. So I always like to use the subtraction. I think that's more complicated. So I'm going to change the cotangent to cosine squared x over sine squared x minus cosine squared x. And this is where I am noticing, what do I have in both of these? I have a cosine squared, don't I? So I factor that out. Why would I factor that out, you suppose? Because do I need a factor of cosine squared on the right? So I'm going to factor out a cosine squared x. And what's left? 1 over sine squared x minus 1. And this is cosine squared x. And what is 1 over cosine? 1 over sine squared. Cosecant squared x minus 1. Wouldn't it be nice if that equals something? squared x minus 1.
Equals cosine.
So are we happy about that? Yes, so this is cosine squared x times cotangent squared x equals cosine squared x times cotangent squared x. And we're happy about that because we solved this one. All right, we got next one. I assume we're solving this? To what interval? Does it give me an interval? Am I doing all solutions? What am I doing? Okay, so this is 2 root 3. I'm gonna say 4 sine x is equal to 2 root 3, right? Because if I move the sine x over to the right-hand side and then flip the equation, I just like to have my 3 functions on the left. A little OCD like that. Are we all right with that? And then sine x equals 2 root 3 over 4, but I can reduce this. Sine x equals root 3 over 2. Gosh, what quadrants is the sign positive? 1 and 2. So alpha here is, if I put this finger down right, it's pi over 3, yes. All right, we'll have to put them. Okay, so I need some ones between 0 and 2 pi. So my alpha is pi over 3. X, my first x is going to be pi over 3. My second x is going to be 2 pi over 3. Okay? Okay. 2 tangent x minus sine x. I'm going to change the tangent to. So this is going to be 2 sine x over cosine x minus sine x equals 0. Now, you can factor out a sine x here if you like. Would you like to do that? Or would you like to find a common denominator? Doesn't matter here. Okay, so I get a sine x out here, and I'm left with 2 over cosine x minus 1 equals 0. So I'm going to say sine x equals 0, or 2 over cosine x minus 1 equals 0. Now, why am I not changing this to secant? Because I know the cosine values, right? I don't know the secant necessarily. So I'm going to leave it as cosine. Are you okay with that?
Yes.
So if sine is 0 here on the x-axis, so it's going to be x equals pi n. Oh, wait. Is this 28 all?
This is fine, all solution.
All solutions. So I was going pi n, an element of the integer set. Could I write 0 plus pi n? Could I write pi plus pi n? Those are all equivalent. That would be all right. Okay, so I'm going to move the 1 over. So we get 2 cosine x equals 1. Okay, so I'm going to cosine 1. Do that? So you get cosine x equals 2. That's a no-go, isn't it? Because this says no solution since, I don't know, maybe it's 1, right? The cosine of x has to lie between these two numbers.
You want us to write
Yes,
that
I
on?
do.
You didn't, you wrote it on my quiz, but
No, you can write no solution, I'm just writing sentence.
you want us to write the sentence?
No, you don't have to.
That's
Okay, but what are you doing? You're preparing yourself for nice calculus and you're communicating. Yes.
Well, cosine of x ever begin with
Yes, it will. It does at pi and 0. but it doesn't live outside that realm.
Okay.
Cosine and sine are same thing between negative 1 and 1. But they don't live outside it. Okay. 29, do we have time for 29? On which one is it? On 29, on which section?
Middle or straight? Yeah.
5-3.
3.
No, you said 5-4.
Sorry?
5,
5, 4?
Yeah.
That's really small, but hopefully I can make it bigger. Okay, what do we like? It's a 3x, and we don't match, right? So we're gonna have to, I'm gonna change this first and see what happens. So we're gonna say what here, sine of 2x, and remember we're solving between 0 and 2 pi. Minus, this is gonna be cosine of 2x plus x equals 0. And I'm gonna leave this sine 2x hanging out here, we'll just see what happens, okay? I like to do that because that's a really easy thing to change at the last minute, yes.
It's
0 pi, okay? 0 pi. Thank you for correcting me there. Is the pi inclusive?
No.
Okay. So I have to do the cosine of a sum, which is cosine, sine, and the sines collide. They're different, right? But I have to watch it because I have a negative here. This pesky negative. Okay, so we'll do this. It's going to be cosine of 2x sine of x minus. Oh, no, I'm so sorry. I caught it just right before you said it, right there, right? Cosine, I'm not following my own rule here. Cosine minus sine 2x sine x equals 0. Okay. I'm going to let's distribute. So we have sine of 2x minus cosine 2x cosine x minus, or plus now, sine 2x. I really want to mix that up. Sine x here. Another strategy of mine is I will leave this alone until I figure out what else is going on. I'm going to change the sine 2x's now. To what? Yeah, you like the cosine first, I like the sine. It does not matter. It absolutely doesn't matter. So don't change what you're doing. Okay? Minus cosine 2x, cosine x, and then this is going to be plus 2 sine x cosine x, but then this is squared cosine x, yeah, equals 0. Now, is there anything common to all three terms?
I'm just wondering how you got 2 sin x and then cosine x there.
This here? Yeah. This is the identity. This right here is equal to this. That's the identity. Okay? That's a good question. All right, but do we see any terms that are common in all of these? I mean, I see this, and I see this. So I'm going to factor out cosine x, and then I'm left with 2 sine x minus cosine 2x plus 2 sine squared x equals 0. Okay, now, this is where I consider what I'm changing that to. I have 3 options. I have a mixed version, I have an all cosine version, or I have an all sine version. And what's the only thing else in here with it? Sine sign, so which one are we gonna choose? All sign version, very nice, okay, so this is gonna be cosine x times 2 sine x minus, the all sign version is 1 minus 2 sine squared x plus 2 sine squared x here equals 0. Cosine x down here, let's simplify the inside here. This is 2 sine x minus 1 plus 2 sine squared x plus 2 sine squared x, which gives us 4 sine squared x, right? Okay, so we get cosine x. Now let's put it in order. Which is the highest exponent? The sine squared. So I'm going to go 2 and 2 is 4 sine squared x plus 2 sine x minus 1 equals 0. Now, is that factor? Yes. No.
Let's just do 5.
Does it factor?
No.
Doesn't look comfortable, no. Okay, well, let's do this one here first. Cosine x equals 0, that's easy enough, right? When does that happen? On the axis there? So x equals, remember, we're doing it from 0 to pi. Pi over 2 from that one, okay? So here we go, we're gonna go sine x equals, opposite of b, negative 2, plus or minus b squared, which is 4 minus 4 times a, which is 4 times c, which is negative 1, all over 2a, which is 8. So we're going to get sine x is equal to negative 1/4 plus or minus, now that's 4 plus 16, right? That's root 20, which is 2 root 5 over 8, which is equal to negative 1/4 plus or minus root 5 over 4. So sine x equals either negative 1/4 minus root 5 over 4. So let's talk about what root 5 is. Root 5 is a number between 2 and 3. So can somebody do that on calculator for me? I mean, I can open mine, but I can switch with you on the side of it. Here we go. Two 2.23, is it really negative?
Maybe 3, but that's just without the.
I'm gonna figure this out. And you say that sine x is equal to, yeah,
Negative 0.30.
oh, wait, this is negative 1.
Oh, sorry.
Try that, let's do that again. I'm sorry, so, we've got, who's that, that's not good. So here, I'm gonna say my fraction, which is, negative 1 over 4, plus or minus, alpha fraction, so, that's the right thing. Second square root 5 over 4. Okay, so that's negative point, what was it, 8 or 9, roughly? And then sine x equals What's the only change I'm making? I'm making that a positive, right? Plus. And that's 0.309. Now, I only want the solutions between 0 and pi. So let's talk about the sign. Where's it negative? Are any of these solutions going to be between 0 and pi? Yay. So I only have to worry about these two, right? So what's alpha? I have a view. It's going to be radians. Am I in radians? I'm in degree mode. So second inverse sine of this. Which is 0.314 roughly. So this is going to be x. Whoops. X equals like 5 or 10 almost, right? 0.314, and then x is going to equal pi minus that. Let's try again. Second pi minus second answer, right? 2.83. So it's 229. So what do you suppose the identities are that we know?
The mix.
All except for the pi.
I would know the double angle. Hold on, let me